Right. Those fiddly questions we did yesterday, where you had to sketch a modulus function and then you had to solve a problem relating to another line, a straight line. The two that we did, you could plot the modulus bit on your calculator. And so the boffins at the exam board get together and they think, how can we cope with the fact that they've all got these, well, they haven't all, but a lot of them have got these graphical calculus these days. So this is an interesting question where you've got some missing values in there. So we're being asked to sketch these two modulus functions, or a modulus function and then one that's been transformed, but we've got missing values that we don't know. The only thing we're told is that A and B are positive constants, they're not negative. So I know this graph will be based around the 2x minus a graph. It'll just bounce when it hits the x-axis, and a is a positive number, so it could be, for example, 2x minus 3 or minus 4. So in sketching that, have a think about what the 2x minus 3 or the minus 4 line would look like, and that's what this one would look like. It then gets shifted up B units. We don't know what B is, we don't know whether it's bigger or smaller than A, but have a think about what that would look like on your graph. So just have a go at those two for me. I don't know if you want to do this on whiteboard. You don't have to. Yes.
Does it matter if you divide all out first?
Where are we dividing?
So at the top, you'll get its own module.
So that one we can plot without any sort of. So let's pretend it's 2x minus 3, for example. So the 2x minus 3 line would look like that, but will be bounced like that, so it goes through 3 and not minus 3. So if it's 2x minus a, that's not going to be 3, that's going to be a. It's worth working out that point as well, whether that's when it equals 0. So the only points they want you to mark on the graph are where it crosses an axis, or where it touches an axis. So remember, this graph is based on the y equals 2x minus a graph, which would look like this and cross the y-axis at minus a, but it's modulus, so it bounces. But that point there is when the 2x minus a graph equals 0, when y is 0. Remember, where does a graph cross the x-axis? When y is 0. Where does a graph cross the y-axis? When x is 0. So that point's a over 2. Outside of the modulus, I'm now doing a transformation. I'm lifting the function up, so it's going to, and b is positive, so I know it's going up. So it's going to look something like this now. And George, what's that point there going to be now? A plus b. A plus b. Okay. Now this next bit we can actually do mostly without reference to a graph, but forgive me, I just want to try and get the whole graph, get you to sort of visualise what this next bit is about. So I'm going to have to recalculate. Oh, sorry. Right, so we're told that this equation has two solutions. Now the left-hand side of the equation is one graph that we've just plotted. So let me redraw that over here. What's the gradient of this part of the graph? What is gradient? So it's the modulus of 2x minus a. So Jodie, what's the gradient of that bit of the graph? 2, yeah, number of x's, gradient, that's right, yeah. We know this is minus 2, that's 2. If I wanted to solve this equation graphically, the next line I'd plot would be the y equals 3 over 2x plus 8 line. Now that one I can actually plot. Its gradient would be 3 over 2, 1.5. So it wouldn't be as steep as this. So it would be a line that was sort of, I don't know, sort of that steepness. And I know that that line would cross the y-axis at plus 8. The trouble is I don't know where 8 is on this axis. I don't know whether it's here or here or here. But we're told in the question, and I've rewritten it here, that this equation has a solution when x is 0. And remember, that means graphically the two lines meet when x is 0. Where on the graph is x 0? Anywhere on the y-axis. So this tells me that these two lines meet on the y-axis. So what does that tell me? Go on. It means a plus b has to equal 8. Yeah, a plus b has to equal 8. Now we're going to work that out algebraically in a moment, but the fact that these two equations equal each other when x is 0 must mean that a plus b is 8. There's another solution. We're told it's when x is c. I can see that other solution there. I can see that c is positive, just like a and b. So c is the x value at that point. I can also tell what that solution occurs when this line crosses the positive branch of that modulus graph. Do you remember when we were doing the inequalities, we got two solutions. We said, right, so this is when the positive branch equals that. This is when the negative version multiplied by minus 1 equals that. So I can go on and do what the question asks me to do. And the question asks, let me just show you the question again. Yes. So the question asks me to find c in terms of a. Right, so I know that this equation works when x equals 0. So I'm going to rewrite it and make x equal to 0. So 2 lots of 0 is 0 minus a. So I'm just left with the modulus of minus a. And if x is 0, 3 over 2 times 0 is 0, plus 8. I was told in the question at the beginning that a is positive, so that means that this will be negative, so the modulus of it will just be a. So we've worked out algebraically, using that equation, what we've seen graphically. The other solution occurs when x is equal to c. But remember, I know that c is when this graph crosses the positive branch of that. So actually, it's when it crosses that. When x is c, I haven't got to worry about the modulus sign. I've got 2c, not 2x, thank you. No, sir?
So you're being filmed?
Well, I am filming myself for Harry and Isabel.
Hello, Harry
I'm
and
asked
Isabel.
in the question to write C in terms of A. So this is all looking very good, apart from that pesky B. Can anyone suggest how I can get rid of the B? Yeah, I can rewrite it as B is equal to 8 minus A, isn't it? So I'm going to rewrite that. Right, go on, you're on your own. See if you can sort all that out. I want it to say C equals something to do with A. This is 1.5 A's. I'm noticing I've got, 1.5 C's. I've got 2 C's there. Go on, see what you get. And if you're confused about why I've not done the modulus sign, remember the graphical bit we did showed me that that second solution occurs when this line touches the positive version of that. So that's why I haven't done the modulus sign. So, 8 cancel out. I can take away 8 from both sides. I've got 2 C's. If I take away 1.5 C's, I've got half a C. And I've got minus 2A. That's my answer. Now, you know, as I said yesterday, these questions are really fiddly, but remember that this is an 8-mark question. 4 of the marks came from the sketch, so that's your 50%, that's your grade C, and then the remaining 4 marks, that's your grade B or your grade A from solving that problem, having a punt at solving that problem. So, you know, this is tricky. This is tricky. And that homework, which covers a huge amount of stuff, so all the way back to before the summer when we were doing simplifying algebraic fractions and partial fractions and composite functions and inverse functions and modulus functions, you know, please give that a good go and let's troubleshoot the things that you can't do together. Right. But I'm going to leave that there. we're going to move on to talk about sequences and series. Sequences and series. This is a sequence, okay? It's a number sequence. We have met number sequences before. This is an example of a geometric sequence. We call those are sequences where we multiply by the same thing each time. But we also have arithmetic sequences, which are sequences where the jump is the same each time, common difference. This is a series. The only difference between a sequence and a series is a sequence where you are adding up the terms, okay? So a series is a sequence where we are adding up things as we go. So for example, this might be the amount of oil being produced by a new oil well. First week it produces 1 million tonnes, second week it produces 3 million tonnes, third week it produces 5 million tonnes. So the sum gives us how many tonnes have been produced in total. So a sequence is just a list of numbers that are related in some way. A series is where we are adding those numbers together because the total is of importance to us. So we're going to look at sequences and series, and we're going to look at two main flavours of sequences and series. The first is arithmetic. So an arithmetic sequence or an arithmetic series is one where you have a common difference. The jump is the same between the numbers. And we met these at GCSE, and at GCSE we described them using a formula. So for example, I would have given you a sequence like this, and I would have said, okay, using the letter N to stand for the position in the sequence, what's the formula for that sequence? See if you can remember how to work out the formula for that sequence. Can you remember it, Lily? 4n minus 1. Well done. Brilliant. Yes, yes. So we've got the arithmetic sequence. The gap is 4. So we know that it's something to do with the 4 times table. So I would always write the 4 times table above the sequence, and I would spot that each term is a 1 less. So yes, that's the formula. And we do occasionally meet questions that still involve that. For example, page 62, question 5. Page 62, question 5. Have a look at that question. That question is asking us to basically do this, write the formula. They word it in a particularly complicated way, and most importantly, they don't tell you the gap. But I'm sure you can work it out. Page 62, question 5. sorry, U6, I'm sorry, notation, U6 means the 6th term. Sorry, I'm sure you worked that out. I was going to do that in just a minute, should have done it first. Trickier this one because I didn't know the gap. So Pat, so talk to me how I could perhaps use this to work out the gap.
What do you mean? Oh, as in.
What's the jump each time? What's the
So you jump 3 times and you move 2 across.
So 3 times my difference, and I should have said that I'm going to use D to stand for difference, is 2. So that tells me that the jump each time is 2/3. So Charlie, how could I then work out the first term, for example? What would I have to do? But what sum would I do? How would I work it out? We've just worked out the jump each time is 2/3. So how could I work this term out? Right, now, the number of jumps is the really tricky bit here. So forgive me for counting, all right? So from 6 back to 1, 1, 2, 3, 4, it's only 5 jumps. And that's a really common mistake, and that's why I will always go. What you actually do is you subtract the positions. So to work out the gap, how many jumps between the first and the 6th term, you just do 6 take away 1. So yeah, so my first term would be 9 take away 5 lots of 2/3. So that's 9 take away 10/3, and 9 is 27/3, so I reckon that's 17/3. And then each time we go up, we're adding 2/3. That's 7, I know that's 7, but I'm just going to leave it as. So this sequence is something to do with the 2/3 times table. So I'll write the 2/3 times table up here. 1 times 2/3 is 2/3. 2 times 2/3 is 4/3. So Beth, what am I adding to get from the 2/3 times table to my sequence each time? 15/3, which is the same as 5. Yeah. So the formula for this sequence is 2/3 of n plus 5. And that's the same, just the same as we did here. We had 4n minus 1, because this was, the jump was 4 each time, so it's something to do with the 4 times table, but it's sort of like a trickier version. Now the good news is that we rarely are asked to do that. At A level, arithmetic series are described in a different way, and I think it's a little bit easier. So let me just talk about a little bit of notation. I should have perhaps talked about it before we did that question. So when we deal with an arithmetic sequence, so we're not adding it up at the moment, we use U to stand for position. So U1 is the first term, U2 is the second, U3 is the third, U4 is the fifth, U5 is the sixth, and U5 is the fifth, and U6 is the sixth, etc., etc., etc. Let's pretend this sequence only has 6 terms. That's it. That's the sequence. So we also refer to the first term, U1, as A, and the last term as L. Some sequences don't have a last term, they just go on forever, but let's say this term. The gap, the jump between each term is referred to as D. And D can be negative, so you can have a sequence that's going down. But if it's an arithmetic sequence, that gap is always the same. You're either adding or subtracting the same. And we use n to stand for the number of terms. So in this case, n equals 6. So the first thing I want to do is to have a formula for any term in the sequence. Which I'm going to call UN. So I want to work out any term in the sequence. And we do it by just saying, okay, to get to any term in this sequence, you start at the first term, U1, which for some reason we also call A. And then you just do lots of jumps, lots of Ds. So for example, if I want to find the 6th term, from the first term it's 1, 2, 3, 4, 5 jumps. The number of jumps from the first term is always 1 less than this number. And that formula is on the formula sheet for some reason. I don't know why. It's not quite an easy one. But yeah, this formula tells me how to work out any sequence starting from the first term. So I know that to get to the 8th term from the first term, there are 7 jumps. So it's the first term plus 7 jumps. U10 is the first term plus 9 jumps. U50 is the first term plus 49 jumps. That's how we would work it out. However, I'll be honest with you, I rarely use that formula because I much prefer pictures. Okay? I much prefer pictures. Now you be the judge. I'm going to show you a question and I'm going to solve it using pictures, and then you can solve it, we can solve it using the formula approach, and you can be the judge. You can tell me which you prefer. Okay? So here's a typical sort of question that we're asked about arithmetic sequences. So the question would say, there is an arithmetic sequence where U3 equals 5 and U8 equals 20. Find A, D, and U20. So I'm going to solve this problem twice, once using my picture approach and once using the formula. And you can be the judge as to which you prefer. Here's my picture approach. So I know that U3, the third term, is, oh, for goodness sake, it's like a railway station. I've got all the windows open. The third term is 5 and the 8th term is 20. So I know that from the third term to the 8th term, 4, 5, 6, 7, 8, 5 jumps. So I know that's 5D, and that gives me 15. So I know now that D is 3. So I know that to get back here, from the third term to the first term, 2, 1, there's 2 jumps. So that is going to be 5 minus 2 lots of 3. That's minus 1. And the 20th term, here I go, I'm at the 8th term, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 12 jumps. Just subtract the 2 U numbers. So the 20th term will be 20 plus 12 jumps, which is 36. I like that way, makes me happy. But some people prefer a bit more rigour. So we can use this formula as an alternative. So I can say, okay, the third term, U3, is equal to A, which remember I don't know, at the start of the problem I didn't know, plus n minus 1, so 2D. And the third term is 5. So the third term is the first term plus 2 jumps. That's what that formula is telling me, isn't it? I also know the 8th term. So the 8th term is the first term plus 7 jumps, and that's 20. What I then have is 2 simultaneous equations. I can whack those simultaneous equations into my calculator, sorry, and I'll get A and D. So my calculator will tell me that A is minus 1 and D is 3. And then I can just use the formula again to work out the 20th term. So U20 is the first term, minus 1, plus 19 jumps. So I offer you 2 approaches, the picture approach or the straight algebra approach using that formula. The formula that says to get to any term in the sequence, you do the first term, and then you've got n minus 1 jumps. So on that same page 62, have a look at question 4. And then have a go at, we've done 5, so have a go at, we won't have time to do all of those, so those could be excellent independent study. I think it's quite important that we can't afford to spend ages practicing, so I think it's important with something relatively straightforward like this that we get as much independent practice on our class as possible so we can rattle through the content in class. So both approaches involve exactly the same calculations, don't they? So to work out the gap here, I did 32, take away 14, which is 18, so D is 6. If you did it algebraically, the 4th term is the first term plus 3 jumps, and we're told the first term, so you end up doing 32 take away 14, and you get the same answer anyway. I'm a huge fan of the picture. Remember, we've already done 5, so we're on to 6 now. So my picture approach to 6 says, okay, going from the 3rd to the 9th, here I go, 4th, 5th, 6th, 7th, 8th, 9th, 6. Yeah, 6 jumps. and it's going down. So it's 7 over 2, 3.5. And that makes it easy to work out the first term, which is going to be negative, because I've just got to take 3.5 away from that, and then take 3.5 away from that, and so I know the 12th term is the first negative term. Did it ask for the value or which term it is? Fantastic, so it's minus 1.5. Now, of course, that was quite easy because I was already quite close to negative terms. So I do want to show you the algebraic approach for this one. So the first thing I would do before I use the formula for this one is I'd work out the first term. So that would mean adding 2 lots of 3.5. So A is 37. So I've got A is 37, D is minus 3.5, I should say, shouldn't I? And they want me to say what's the first negative term. So I would ask, when does this drop below 0? So it's an inequality. So, and n is what I'm after at the moment. N will be the number of the term, the first term that's below 0. So I've got 37 plus n, I don't know n, remember, that's what I'm trying to find out, times minus 3.5. That looks dreadful, doesn't it? But it's that times that, so I'm going to quickly multiply that out before anyone notices. So I've got 40.5 minus 3.5 n is less than 0. So if I divide by, there is, divide 40.5 by 3.5, I get 11.57. And of course you can't have the 11.57 term in a sequence, so what that means is the 11th term will be greater than 0 and the 12th term would be less than 0. So 12th term, and I can then work out the 12th term by going back to here and working it out. So that's just an inequality approach. If the picture approach, if it was like the 400th term was the first negative term, maybe this wouldn't have been so good. Maybe the inequality approach. It's ludicrous to use that in this case because it's just a couple of terms on, isn't it? So, independent study, I would propose that you had a look at those other questions. I want to finish though by talking about series. So we've been talking about arithmetic sequences, which are just a list of numbers where the gaps are the same. But if we now talk about arithmetic series, we need to add up the terms. And I want to show you a quick trick which you can use to add up a list of numbers, which actually derives the formula that we use and the formula for the sum of an arithmetic series, which is on the formula sheet. So I'm going to really impress you by quickly adding up the first 40 numbers. Now the first 40 numbers is an arithmetic series. 1 plus 2, A is 1 and D is 1. But this works for any series. Has anyone seen this trick before? Prepare to be impressed. What I'm going to do is, I'm going to write out my series, okay? I'm then going to write out my series again, upside down. I'm pretty sure I would have done, yeah. What do we notice about the corresponding pairs of numbers?
41.
They add up to 41. How many 41s?
41.
How many 41s are there?
40.
40 41s, yeah. So the total of everything I've written up there is 40 times 41. Now, is that the total of my sequence, the first 40 numbers? how many times have I written my sequence?
4 times.
Twice.
Oh, yeah, so.
So the total of my original sequence is a half of that. So it's 20 times 41 is 820. So so that works for any arithmetic series. Okay, for any arithmetic series that works. Where does 41 come from? Where does 41 come from? What is 41 in the context of that series?
What all the numbers are?
If I'd listed the first 20 numbers, what would the two numbers have added up to? 21, yeah. It's the first and the last number, isn't it? 41 is the first number in the series and the last number in the series added together. So the sum of the first n terms of an arithmetic series is a half times n, 40 was n, the number of terms, times the first and the last number added together. And that doesn't just work for consecutive numbers, it works for any arithmetic series. With my first 40 numbers, I had 40 terms, n was 40. The first and the last term added to 41, and that gave me double my total, because I've written sequence, so it was half of that. So we actually tend to write that like this. Now what if we don't have the luxury of knowing the last term in our sequence? I can work out the last term. The last term is also the nth term, isn't it? So just like A is the same as U1, L is the same as UN. And that, using our formula, is the first term plus n minus 1 jumps. So I can rewrite my formula replacing L with and that gives us the formal formula for the sum of an arithmetic series. It's on the formula sheet. You don't need to understand where it's come from, but that's what we come from. So if I want to add up the first n terms in an arithmetic series, I use that formula. A is the first term, D is the jump, n is the number of terms. That gives me the total. So what we'll do tomorrow, yes, it's tomorrow, so isn't it, is we will use that formula to solve some problems. Good stuff.